So yeah, today I'm going to talk to you about A/B testing, about things that are really great about A/B testing, things that are not so great about A/B testing, and how to solve them and how to manage them. Um, when I was preparing my slides, I kind of checked the agenda for the conference, and I saw that a lot of the talks are very machine learning, engineering, tooling kind of focused. So if you are a machine learning engineer and you think, what does this have to do with me? I promise at the end, or towards the end, I will tie it all together also to problems in machine learning engineering. So stay put. Um, like I said, I'm going to start talking about A/B testing. Before that, a quick introduction of my employer that was so gracious as to fly me here today, and a little bit about myself. I'll talk about why A/B testing are so great. I'll talk about why they sometimes aren't so great, and what does that have to do with machine learning. End up with some suggestions of what you can do in order to kind of mediate a lot of the problems, and we'll have some time for questions at the end. So a few words about my employer. Just by raise of hand, how many of you have heard about Shopify before? Okay, good. Because when I joined the company, which was a while ago, I used to tell people it's the largest company you've never heard of. Because the company basically provides infrastructure for e-commerce. So a lot of the time, all of you probably bought something from a Shopify merchant. You just never knew that you did, because we are in the background, basically powering everything from the front end, back end, logistics, all kinds of integrations and different services from finance, fraud, and basically spanning the whole spectrum. It's a large company, originally founded in Canada, and now operating without offices all over the world. So I'll mention it at the end. We are hiring. A few words about myself. So I'm a senior data scientist at Shopify. I've been working for almost 20 years now in a lot of different industries. If you talk to me for more than 5 minutes about anything that has to do with machine learning or statistics, you will find very quickly that I'm a Bayesian. I call it Bayesian by belief, but I do recognize that a lot of the time, as data scientists, the most important machine learning algorithm we can provide to the business is maybe the average or median, because that, if you can answer the question in the right time and impact business decisions, that has a lot of the time much more impact than any sophisticated deep reinforcement model you can develop. So that's something I kind of hold very near and dear to my heart. Yeah, in my free time, I do try to do a lot of sports, even though you can't really tell. And I joined, actually this year I decided I'm going to find exactly how fit I am and join a very large international competition. It's called the CrossFit Open. I think more than 200,000 people this year. And I discovered that I'm a very, very mediocre CrossFitter. They provide a lot of data. It's really cool. They don't tell you just good, bad. They actually give you the exact percentile. So I know exactly where I'm ranked, which is not great. But I think finding out you're not great is also something good to find out every once in a while, right? Okay. So let's talk about A/B testing. I'm assuming some prior knowledge that at least all of you have heard about the term A/B test and you know what I'm talking about. Kind of in a nutshell, you've probably seen a million times different versions of this cycle. In a general kind of way, we can talk about, first of all, kind of figuring out what you want to ask. What's the question? What's the business question you want to answer? Next step will be to decide. So it can be something like, we want to try a new version of our recommendation engine, a new design for the website, a new product that we're offering if we're in a fintech company, and anything that can, anything you want to basically test versus the existing solution that you have. We then decide on what we want to test, or kind of what we want to measure, I would say. Is it clicks? Is it money? Is it user satisfaction? Or is it lifetime value? We then create 2 different versions, or n different versions. We run the different versions in production, collect the data, measure the results, and decide which one kind of won the competition, right? It's a very, very simple concept. And it's a very effective concept. Now, just by raise of hand, I'm not going to question you about this. Anybody here kind of can tell me why, or can answer the question, why do A/B tests work so well? Just by raise of hand, and if you don't want to participate, feel free, it's fine. Okay. I don't see a lot of hands up, which is fine, also if you choose not to participate. The reason, kind of the core reason that A/B testing works so well is because we randomize. If you want to compare 2 versions of a website, or 2 products, or like I said, 2 recommendations and 2 recommendation engines, or whatever you want to compare, you want to make sure that the groups that got version A and the group that got version B are very similar to one another. Because If, for example, for whatever reason, we divide our users into two groups, and one group is actually over the age of 40, and another group is under the age of 40, just as an example, we will have a problem, because then what can we say? What can we say about the impact of the new version? Did it come from the product, or did it come from the fact that the users were older or younger, or anything else that might happen here, right? So we want to compare. Basically, we want to make sure that the only difference between the test group and the control group is what's called our intervention. That's the name in medicine. Or basically is the test, right? We want to make sure that that's the only difference between the two groups. And randomization is actually a very good way to do that. You can, in theory, if you know maybe not a lot about your users, you can kind of divide them into different groups and make sure manually to balance these groups. And that can also work as a form of A/B test. But randomization gives you a nice statistical guarantee that if you randomize correctly your users or your sessions or whatever else you're trying to, bank accounts or whatever else you're trying to randomize here, you will end up with two groups that are pretty much similar to one another. And by the way, if you know a lot about your users, you can and should test that every time you run an A/B test, sometimes called an AA test. Basically, you just want to make sure that your groups are actually, you finished randomizing. Like I said, it's a statistical guarantee. You might end up sometimes actually with groups that are very different, and you want to check that even before as you're running your A/B test. That's great if you know know a lot about the things that you're measuring. I'll be talking a lot about users or buyers here, but again, you can generalize this to anything else that you're testing on. And it's great if you know a lot. So, I don't know, I've worked in the fintech industry, and banks usually know a lot about their customers. They have to know about it. But if you are in the e-commerce space, and we're talking about buyers or even visitors, we don't know a lot about them. Actually, we know less and less the more regulation tells us exactly what we can and cannot know, and the more we have tracking blockers and all these kind of things. So we don't know a lot about your users. And this is the amazing part about randomization and why A/B testing works the way that it works, is because you don't just control for what you see, you also control for everything you don't see, right? If we used to have this example, we would never know the eye color of the customer. We would just never know that. And maybe that has some impact on the decision or on the preferences. We would never know that. But if we randomize, at least we have some guarantee that these two groups should contain a good mix of eye colors, even if it's something that we never see. So, and another honorable mention, I would say, is the fact that randomization also works really well with streaming and with complex data types. So it's a really, really, not just convenient, but really efficient and great way of making sure that your results are meaningful. Now, let's look at a quick example. Pet beds. How many of you, by the way, have a cat or a dog? Okay. So it's a nice thing, a nice thing to have if you have a cat or a dog or any other animal that likes to sleep in this kind of, in a bed. And let's assume that we have in January, beginning of the year, the PM comes to us and they say, okay, we want to test a new model, or we want to test a new configuration for our website. For simplicity, let's assume that's the only thing we're selling, different types of pet beds. Or maybe we want to test a new recommendation engine against the existing one. And we say, okay, let's set everything up. We set up the randomization. We run the test in February. As you can see, results are already improving because maybe 50% of our users already got the new version, so we should see some changes to the numbers. And at the end, when we conclude the experiment, we discovered that there's a 5% increase in conversion rate. Amazing, right? That's really good. That's really good. Everybody's happy. Let's launch. Let's put the new version into production. Come May, things not looking so great anymore. And as we get into summer, things are actually looking pretty bad. And again, let's assume things are pretty much, we haven't seen anything that should lead us to think that things are working, are not working. Where can that come from? And that comes from, and I think this is the point I wanted to highlight here, we don't know who this pet bed is intended for. Sometimes you're lucky and you work in an environment, like I said, where you know a lot about your customers, but sometimes it's something that we will never know because the customers don't tell us. It's the same bed for cats and dogs. I don't know who the customer is buying it for. And what happened in the background? So this is, again, a possible explanation where we had a 50-50 split in our population with cat owners and dog owners. In general, when we tested the new design, what happened? Cat owners loved the new bed. They really, really loved it. Dog owners, Not so much. Actually, they didn't like it a lot. Again, like I said, this is underneath the surface, something that would never be observable for us unless we actually go and run some questionnaires, but that's not as effective. And what happened under the surface, like I said, without us knowing, some subsection or some segment of the population really liked what we had to offer. Another one didn't so much, but overall we had an improvement. And then 3 months later, for whatever reason, we now have more dog owners coming to our website and conversion drops, right? And this is, again, simple mathematics. The slide will be available if you want to check me on the arithmetics here, and please do. I can say something happened. When I say something happened, it can really be anything. And it can be something like seasonal changes. It can be maybe during COVID, people prefer to adopt dogs. Maybe our marketing department did something that now targets dog owners more than cat owners. A lot of things can happen around. So as you can see, with all the good intentions in the world, we actually ended up with a product that's maybe worse in a way. So what went wrong here? There are basically two assumptions when you're running an A/B test that you need to be at least wary about. One is uniformity. Again, it's this idea that if I see a 5% change, it is uniform across all the segments in my populations, the one that I see, and especially the ones that I don't see, right? That is a very strong assumption. And the second thing, the assumption that's never right, is that everything stays the same or the things are stable because everything changes, right? That's I think we've known this since a while, like 3,000 years now? No. Yeah, close to 2,500 years now, we've known that things change. And if you get a mix of both of these things, this is exactly what you would get. You can get very, very dramatic changes to the results, even though everything was designed and planned properly. So, as I said, and this is just a single test. For a single test, you can have changes to population, to demographics, other things I mentioned before, changes to the ecosystem, maybe a new competitor comes in and changes the competitive landscape, another reason to maybe kind of think again about what you're doing. And this can be, again, a very long list of things. And this is only for one test. If you have multiple tests, well, I want to go into these one by one to get into a little bit deeper into each one of them. If you have multiple tests, then you have even more disruption. I mentioned marketing before. Okay, marketing changed their strategy, unbeknownst to you, right? And suddenly you have a different population coming in. Maybe not just marketing, maybe the landing page changed and you're working on checkout. Maybe something about the product page change and you're working on something that has to do with post-checkout situation. So basically everything upstream from you, by design, will change over time, right? And you need to be able to at least account for it or at least handle it in some way. So that's one kind of disruption. Another kind of disruption that can happen, slightly different than just your test results getting better or worse, you can also end up, if you run this kind of, if you are in this kind of situation, you can, theoretically at least, end up in a situation where in different parts of the product you reach different conclusions about similar things. So something that I've actually seen happen, I think it was payment method sorting, where basically different parts of the website were sorting payment methods in a different way, which if you are a customer and you go and you start looking for your method or you have your preferences, this can create a very confusing experience. And again, you can take it into features, you can take it into a lot of other things. Last but not least, a little pet peeve of mine, I would say. I call it the product flux or the slippery A. I hear from companies sometimes very proudly, and maybe justly so, every single one of our users is at least part of some kind of test at any given point in time. And then my question to them is my question back is, okay, so what is your product then exactly? At any given time, your product is basically changing. And it's almost a curse, in a sense, of the tech domain, especially of software, that we can change everything, everywhere, all at once. If you haven't seen the movie, it's a really good one. We can actually do that, whereas if you look at something like medicine, research, or biotech, you would usually, if you are recruiting patients, for example, for a trial, you would usually try to recruit patients that are not part of another trial, because that can really disrupt your baseline, right? That can be very damaging to what you're doing. So you usually try to recruit patients that come from this, let's say, status quo. Industrial design, usually there are some limitations either from physics or from the industrial process, or it just tends to be a little bit more rigid. It's harder to change machines. And in software, we can kind of do whatever we want, right? We can change things all the time. And if it is something that you really need to do, let's talk later about bandits and what you can do with that. Maybe A/B testing is not exactly what you should be doing. But maybe there are other ways to handle this. Because, and again, think about the problem where it's not just that the product changes over time. You run an experiment over, let's say, a month, which is, again, depending on the volume you have, might not be a very big experiment. You run an experiment over a month. In that month, your A versus B is not the same A versus B that you had at the beginning of the experiment. So this can create a lot of disruption to the results you're getting, right? So, and this is how you end up, and I'm sure we've all seen this. A lot of products that kind of look like this. Like I said, I think it's a more typical situation in the software world where you can really change a lot of things. And I'm not even going into the whole discussion about p-value, what's called the p-value random walk, and which statistical method can lead you in a better way or in a worse way. You can, even with the best intentions, you can end up in a situation like this. I promised for machine learning engineers. Why do you care about this? This is A/B testing. I know we know about feature drift. It is a problem. So, like I said, all the problems I described to you about stability, about changes, about testing something, or even your model against another alternative in production as production is changing over time, same problem as before. You can look at it as some form of feature drift. Those of you who are familiar with the term, the idea is, again, that your input changes over time, so you need to adjust for this. Same problems that you have with upstream data, same problem that you have with other decisions in the product, and same problems that you have, again, different models can end up with different recommendations or different optimizations for the same user in different areas of the product. It's very easy to see that, when marketing pushes one thing, but then pricing does something a little bit different, right? Again, this is something that can happen a lot. I will say, again, not the topic for today, but if you really want to build a good machine learning model, you do need to think about some kind of randomization. It's not exactly A/B testing, but if you maybe focus on some key features, especially the ones you're trying to influence, and basically take them as some form of an A/B test where you can actually learn about causality. It's a complicated thing to do. You might need to kind of decide exactly where you want to focus, and there are some ideas I'll mention about like baseline adjustments where you can control things. But in general, we are in the same world of problems. Now, and again, with machine learning, we've all seen these examples, right? Where I want to say something like a new kind of population comes in, and suddenly your recommendation engine that works 99% of the time really, really well, for that 1% of users, you end up being in some, Hacker News headline that, oh my God, look at what this company recommended for me. How dare they? So again, it is a problem. So what can you do as a data scientist? Some really basic things, and this applies for A/B testing, and this applies for machine learning models as well. Monitor your features. Even something as basic as just looking at things every once in a while, just to make sure that they look the same. Kind of the eyeball test. As humans, we're really, really good at detecting these kind of changes where sometimes, automation doesn't work that well, but at least make it accessible and part of your process. If you are working on a lot of models, on a lot of features, you can automate a lot of that process, just looking at differences, t-tests, Mann-Whitney, whatever statistical test is your favorite, or if you're looking at distributions, Kolmogorov-Smirnov is a really, really smart idea, and looking at kind of shifts, or let's say big shifts to your distribution, underlying distributions, it's a really nice way of doing that. If you are working again in machine learning world, there are all kinds of ideas of the feature shift models. Sorry. The feature shift models, where if you are working with a lot of variables, you can kind of try and figure out how everything works together and where the changes are coming from. Again, not going to talk too much about them in this talk, but come and talk to me later if you want to talk more about this. And the most important thing, and I know you've probably seen a lot of solutions and ideas in this conference yesterday and today, talk to your platform provider and try to automate this. Because all of these are things that are pretty simple to automate, alerts that are pretty easy to set up, and you can and should do that for everything in your data. Other things you can do, if you want to take a few steps further, maybe you're working in a narrower domain where you don't have that many features, you can actually build a model. Even for, when you're running an A/B test can also be kind of analyzed as a way, as a model, where you can try and understand how different features influence different things, and that can help you to generalize if your population changes a little bit. At least at least for the things that you know. Again, if you know a lot of things about your users, and if you have that kind of pretty good coverage, you can use that. Same thing goes for causality and upstream changes. So again, something like, again, conversion model, and taking into account things like marketing budget in your conversion model might not be a bad idea. And if you can, at least in some domains, coming from the pricing world, if you can isolate a few variables where you are focused on, you can treat other variables as things that you're not going to touch. And then there are all kinds of approaches, usually with some nice techniques on machine learning methods and also logistic regressions, if you only want to do that, where you can kind of, on a periodical basis, kind of adjust just the baseline. So there are ways to do that as well, without refitting the model every single day. If you're refitting your model every single day, again, maybe we should talk about bandits, and come talk to me about bandits, and maybe we should that will be an interesting discussion, like why do you need to refit every day? Yep, and so that's kind of, those are ways of doing it, and basically the whole notion of this comes from kind of understanding causality, right? If we have a good understanding of causality of features, if we're not working on a problem that's huge and super, or in an environment that's huge and super complicated, it's something we can do. But what if we are? What if things are really complicated? What if it's really difficult to build these models, or if we have a lot of unknowns? Another option, which I've also seen happening, I call it the ship of the damned. Basically, an interesting idea, if you can do it, is to keep a small percentage of your users at any given time as, I call it like the eternal control group. Basically, the group that keeps getting the product from maybe a year ago, maybe even 2 years ago, depending how you evolve your product. Basically, think about it this way, that there is a baseline at any given time. We develop features and then kind of close another version. And every time we compare the new vision of the product to the old vision of the product. So we have to keep a small group of users on the old vision of the product the whole time. Business-wise, this is something that business owners sometimes have trouble digesting, because we are, in a sense, sacrificing, right, something here. This is where testing has a cost to it, and that's something that needs to be communicated. Because if the new product is amazing, 5% will stay on the old version that's not so amazing. It's not something you can always do, especially if that's something, there are things like, call it, let's say, reputation issues. Users that complain that they didn't get the latest feature from their favorite social network and start complaining about it, and that creates a problem, right? Why are you discriminating? Why am I getting a bad version? But sometimes you can do it, and that's a really, really, I want to say, a safe way of making sure that you can compare to the right thing, right? Even if something changed along the way, you are still comparing the new vision to the old vision. You're not alone in this, meaning that the onus is not only on you as data scientists to manage this problem. Something that I think PMs also need to understand and learn, and if you're lucky enough to work with a PM that understands this, it's a great thing. That think about testing, in a sense, as a limited resources. Like I said, if we're going to test every single change to every single color, and every single test to every single font will end with thousands of tests, oh, that sounds great, right? But again, we'll end up in the same situation with the same problems we had before. It's sometimes on us as data scientists to push the PMs to think more about complete visions, maybe, and test them. Basically, think about testing as a resource or as a budget where you need to spend it where you want to spend it, on the important things, on the important features that you want to test. So think about it not as a kind of, maybe not as an ongoing process, maybe kind of slow it down a little bit and think about complete visions to test against one another. That's one way of, again, just dealing with it from the organizational perspective, no changes to the process itself. Again, coordination, communication, it has to happen, right? Upstream changes. Product owners need to understand the impact of other products on what they're doing, so they need to be able to, again, communicate and at least prepare for that. And yeah, like I said, coordinate across products, across domains. And one thing I'm interested in, periodically, if you really made an important decision or a core decision, some significant changes to your product, periodically try and revisit that somehow, either with the internal control group or maybe something else. Try to revert a feature back and do that. Because when I mentioned before, kind of, if you saw at the beginning, the first slide I saw was a cycle, right? Just by raise of hands, if you ever had that experience, I'm curious. How many of you have seen a case where, again, you tested something new, You adopted a new feature, and then let's say a year later, you retested it in a way. How many of you have seen that happen? I think I see, oh, okay. Not a lot. So I think it's kind of typical, a typical thing that happens where we say something is better, okay, it's better, check, let's move forward, right? So if you have big important decisions about your products, it is a good idea to sometimes revisit them and at least have the facilities to revisit them because, like I said, if you don't, you might be kind of, again, from if you talk about optimization, you might be getting lost in this random walk into this very local minima where actually if you took a step back and looked at the whole product as a concept, you can actually make something much better. Again, testing visions against visions. And with that, questions? Yep.
Hello. I'm interested to know how do you do exactly the A/B testing? Do you use anything like a dedicated SaaS like Optimizely, or how do you do it?
So in Shopify, currently we use a kind of a homespun solution. We developed our own platform basically for A/B testing. So again, it's a whole platform. Either the engineers can inject the events, basically inject events that fire, the assignment, and that controls also the assignment and the allocation and everything. Yeah, so we have our own, in Shopify, there's a home-built solution.
Okay, one more. How do you see the AI/ML going hand in hand with the A/B testing? Because since you have lots of data and you can have even multivariate testing, how can you take advantage of the previous experiments to let the ML self doing this?
So there are a few kind of, I would say a few topics here, I think. One of them is, like I said, causality, which there is a lot of work about this in ML right now. I want to say it's really cool that, again, coming from statistical background, it's sometimes funny to me that ML papers rediscover really deep insight from the 50s in econometrics that happens sometimes about causality. So if you can have some structure of causality, you can, like I said before, bring in information from other parts of the product, upstream information basically, right? And integrate that into your model. So if then there is a population change, right, because of marketing spend, and your model can support that, then your model at least should extrapolate up to some point, right? It's a difficult thing. You might need to, again, retrain your model. This is why we retrain our models, right? Every period, every time. But you can actually make the model more flexible in the sense that if you get upstream information, your model will be able to extrapolate better, right, for new situations. At least should. The other thing I think I can talk about in terms of machine learning is, like you said, the multivariate drift. And here it's very similar. It's this concept, again, I'm not going to elaborate too much, but in a way it's a very similar concept to propensity scores. The idea is that you look at the data before and the data after. You kind of treat it as two different groups. And if you can kind of find or explain one of the difference, if you find a significant difference in the before and the after, and you can explain it from using one of the features, that is what has changed, right? And again, there are all kinds of thoughts about like randomizing the assignment and everything. You can do all kinds of tricks there that will make make this more informative. But basically, that's the idea. So not just looking at one feature and saying, okay, age has changed, the average age has changed, but you can also look at age, income, and other things and say, okay, if you have a good causal model there and you can say that actually the change is actually because we are now targeting higher income or lower income or a different geography where age is different. And that is the cause of the change, right, to the feature set. So, and then that also goes back to which part of the model maybe you want to retrain or if you need to retrain another part of the model. Because if it's something that we want to influence versus something that we can't influence, there's a lot of things to say there. Yeah.
Are there any more questions?
Hi, you mentioned having a kind of Bayesian approach. So when you do A/B testing, are you using a Bayesian test or are you using more like a p-value?
So in Shopify, I think we kind of went all the way. Well, I think the platform supports everything, but I think a lot of at least we made sure that the defaults would be some kind of a Bayesian approach. It's all the problems I mentioned here, I think also exist with the Bayesian approach, especially, and maybe other problems where again it depends on your prior, depends how you set it up. There are a lot of things to say there, but it's definitely better than a p-value in a sense, right? P-value, I have a lot to say about p-values, especially that they usually don't mean what you think they mean, or if you do know what they mean, then they sound really, really bizarre. And they can and have been shown to lead to exactly that, what we call the random value, the random walk, right, over different hypotheses. So that can happen there. Bayesian A/B testing is basically you just need to set up your prior, right? It's a very simple univariate regression, so you can set it up this way.
Thank you.
And just to mention that, and then if you do have a model and you do want to impose causality, that is something that you can do very efficiently with a Bayesian model. So that's actually really great.
Okay. Any more questions?
Hi, thanks for the talk. I really like the idea with the eternal baseline, but I wonder whether you're running at risk to actually eliminate randomization, because initially you can say, okay, we randomly assign guys to either this eternal control group or another group. But then they're stuck for 10 years with this old software. And on all subsequent A/B tests, they will not be randomized anymore. And the other issue might be that after 10 years, their age might be higher than with the experimental group.
Yeah. So if you are doing it, like you said, it's not like you take a group of people and say from now on. If you look at it from a inflow-outflow perspective, right, then you need to look at new users and assign 5% of your new users to that control group every day. Every single one that comes in needs to go through this randomization, and 5% of new business, existing business, has to sit in that control group. And then at least the demographics should be, right, very similar. Everything that happens after that, you're right, in a sense that, for example, attrition will be higher there. Probably, maybe, if you're doing the right things. Sometimes not. That's, you also sometimes discover they actually like it better. But so it's something that you should be able to, again, if you continuously assign people to that group, it's fine. I wouldn't go with 10 years going back. Like I said, I think you can do that, and I know again, going back to pricing, sometimes you just have, price lists versus some kind of personalized prices, or recommendations, kind of standard products versus some personalized recommendations, right? You can kind of play around with that, and that kind of stays very stable over time. If it comes to a more complicated product or something where you can't just keep an old version all the time, like I said, I think a better strategy would be to think about like these grand or bigger visions, where you get to a vision, people stay in that vision. A group of 5% will stay with vision 1. You keep building it until you decide, okay, this is the new vision of the product. Maybe you actually relaunch something even publicly, and then everybody goes to the next one. And then again and again, you kind of just lag them behind kind of one major version in a way. Again, versions don't exist anymore, right? We're all doing CI/CD, so that don't exist, but at least some kind of a vision that exists there, and then if you can just keep them at a lag.
Thank you.
Thanks for the talk. I have a question follow-up. So you said for this, keeping a small part of your traffic on the version 1 and iterating on version 2 for like 2 years. That means that your code base still need to be handled version 1 and every new thing on version 2. And I think it can slow it down the overall platform, because you need to change data and things like that.
So, absolutely true. I think maybe years is not, again, especially for software, years would not be the horizon, the time frame I would be thinking of. Maybe months, even less than that, you know, depending how quickly you change things. Although, again, to be honest, like I said, if the message is that we need to change, we need to, you know, we're rolling with the punches, we change everything everywhere all the time, every day. If you look at the website a month ago, it's going to be very different. Maybe we don't need to do A/B testing, maybe we need to do something else, which is much more complicated and like I said, in terms of maintaining multiple versions, multiple even backends sometimes, that's even next level. And some companies do that. But I would say again, if you can, it is true, it is a very good point, and this is where, like I said, there is a cost. Testing doesn't come without a cost at all. There is a cost, and that might be one of those costs that you need to understand. And as a PM, as a product manager, you need to at least take into account. Like I said, maybe not 2 years back. That seems to be a little far for software, but maybe a few months back.
The last question.
Hi, thanks for the talk, very interesting. So this is more a kind of philosophical question somehow, and it's that, so it seems that A/B testing forces you to only evolve through incremental changes, right? So you are on, in other words, you could not find the iPhone by A/B testing the iMacs, right? So my question is, how do you deal with that? And because I mean, they add value, A/B testing adds value, but in the long run, right? It seems so. Yeah. Thanks.
I want to say that's maybe a separate talk. In Shopify, we do a lot of pilots, for example. There are other ways of doing this. And in general, A/B testing, and this is something that, you know, again, I think as data scientists, maybe we have a clear understanding of this. PMs sometimes need some education, that this is not a replacement for having a vision, right? And we can look, kind of micro-manage small features, test this or this or this, but at the end, if you don't take that step forward, and look at a complete thing to make sure that it makes sense. That's on us as data scientists maybe to stop this, but that's actually also the responsibility of other people on the team, right? To make sure. And this is why I mentioned, I like the thinking of like, think about visions rather than on features. And if you are testing visions, if you can, by the way, again, there are problems, for example, especially if you're very public, like marketing language, right? Or marketing campaigns that can work if they're individualized, but public marketing campaigns, in general, you can't really do even A/B testing there, right? So there the problem also, like I said, if you are really testing something that's brand new, incrementally I wouldn't get there. This is where I would think more of pilots, and there is a whole different topic about how you can learn from them and generalize from them, but that's a separate thing.